Everybody, tune in to Recent Tartarians.
Recent Tartarians. Recent Tartarians. Recent Tartarians. Recent Tartarians.
Hey, everybody, tune in to Recent Tartarians.
Recent Tartarians. Recent Tartarians.
Hello, everybody. Welcome back to the show. So, Parker Emmerson is sitting down with us right now. Literally, good to see you. And then I have been trying to get a show together to talk about canonical physics for a while, and then we were going to do a thing on the 12th, and then there was like a jumble. So we decided to do it over the weekend. I think this is great. We're going to have like a Quantum Sunday kind of thing going on here. But Parker, please tell us a little bit of your background. You know, what I see the poster behind you. You're clearly into.
This is like my art from the equations, but
Yeah, I mean there's a great way to put it. He makes art from equations. All right, so Parker, who are you? Tell us about yourself.
That was how I was putting it for a while, but originally I still believe this is that God made all these forms and equations.
Right, yeah, like the sacred design, sacred geometry. It's like the proof of beauty. Yeah, absolutely.
Yeah, and like there's so many analogies to spirituality and religion that are embedded in the equations, the pathway that but I originally started at Antioch College, and I did physical chemistry 1, physical chemistry 2, chemistry 1, chemistry 2.
Chemistry is like football to me.
They shut that college down.
Why they do that? Not enough people.
It was money. It was money. They had all these satellite universities, and then the satellite universities that were offspring from the college didn't want to support the college anymore, and they shut it down.
Brutal. Man, so like it's funny when I was looking at chemistry, I always compared it like to football plays, because you've got these reactions that things have to do. Carbon has to react a certain way. You expect. So it's funny because in these chemistry formulas, what we're seeing all the time is delineations that you can expect at like the Tchaikovsky reaction, for instance, or something. You can expect certain delineations to happen. So they really are beautiful, blossoming, interesting things. What did you see when you got into chemistry that, turned you on to the universe or something about it?
Well, I made
mechanisms.
Well, I made this decision just after the first year that I was going to make my own scientific discovery. I said, I'm going to make my own scientific discovery. And so I started, and I said, what angle do you perceive two equal line segments in golden ratio with each other? And then I calculated all of that. And I don't know, that was at this, and my chemistry is really rusty. Like, I'm not like great at chemistry or anything, but I do know that they can't explain the electron and why it takes different orbital shapes without using infinity. They have to use infinity in order to come up with this explanation.
The one electron, right?
But my whole thing is like, people are counting forward from zero, something that doesn't exist, instead of counting backward from infinity. And like symbolically, you can do all the same operations you can do from infinity that you could do from zero. It just makes a whole lot more sense. And so my whole thing is like, and this sounds a little weird because, oh, you don't believe in zero, and oh, you must not really understand or something. Like, no, I can conceive of zero, and I can also conceive that I don't think that's the right, direction for math to continue to proceed. But transcendental logic using balancing of meanings of infinity is where I'm going. So there are different meanings of infinity. And of course, this is not, and then we'll get into it because I really do want to explain a lot of the theory that I've come up with. If you were to count back from infinity in base infinity with your index as infinity, you would literally just have this list of symbols that goes on and on and on forever.
You replace zero with variables because it's assets, right? So you're saying there's 10 assets instead of 10 zeros. Yeah. Or infinity.
You would have a list of symbols. Each symbol is different than the other symbol.
Right. And apples and oranges,
Every number would have a specific symbol for it. And
So we're building this world of variables, and a lot of time we use digits, but it seems like so much of the math is better off when we're not using digits and when we're using concepts. Object oriented programming or geometry, and you've done a lot of work with geometry as well. So how does geometry help you represent numbers and variables and concepts?
Well, so I started off, and at that time, that was the whole thing with the Terence McKenna time wave zero. That was in like 2007.
Right.
And at that time, they were saying this was going to be the apocalypse and everything.
It was weird. The 2070s,
Jesus
I call
really
it.
did return.
Yeah.
I believe Jesus really did return for an instant in that era.
Really?
Yeah, I do. And so
that fits with Jehovah's Witness and a lot of people. I mean, the Unarius cult, Subgenius had their X Day. I mean, there's a lot of things that would play in. So what do you mean by that? What do you think?
But anyway, I mean, it's a really personal and like experience. But what I would say is basically, I had the lines of sight to the two equal line segments, and I did this whole diagram where I found, when you perceive two equal line segments in golden ratio with each other, you can either grasp the entire set of line segments as a whole line segment, or you can zoom in on one or zoom in on the other. And that's actually going to change how you focus and which one's going to be bigger or smaller, right?
Right.
So that was just realizing that was like a big, long journey.
Well, I mean, so you use Euclidean. If you use Euclidean geometry, you have expectations, but not all of those expectations have to be found in nature. And we're seeming to find more and more odds with Euclidean math, where Euclidean distance.
Yeah. Yeah.
It seems like two golden ratios. That's kind of the idea. Like, how do you get the perspective to remain? You have to.
So you could even pull up like the sphere of realization document now, and I could show you. I can show you where there's a golden ratio in there.
Let me see if I've got that one right off the top. Right now, I can see I've got the equations with 12 solutions and 8 solutions.
Yeah, I mean, just the fact that there are these, like, just a few logical steps from, say, the difference between two arc lengths. Say you have one arc length and another arc length, and you take the difference between those two arc lengths, and it's a different arc length, right? Well, just a few steps logically down that path, you get these like really higher dimensional equations, which suggests that there are like these 12, there are 12 dimensions all around us.
12. Okay, so we've talked about 10, and we've talked about, so we've got the time is 4, we've got multiple choices at 5, we have multiple infinities, we've gotten up to 10. 11 counting 0. Okay, we've done that. So tell me about 12. What am I missing here?
Okay, go down. You can go down.
Okay. How far down should I go?
Well, go down. We can talk about that one too, but
we can go back. Yeah, but I'll go down.
So here, take this one for instance. There it is. Root. See right here, 12-dimensional. That's a 12-dimensional angle. Usually people think of like dimensions as like, well, this is a distance and that's another distance and this distance, and that's how dimensions work. But angles can actually be higher dimensional too.
Okay. So when we're using
these coefficients, what I've been doing was I've been taking these coefficients. You see these hexadecimal coefficients, 30, 43, 50. They all have varying numerological significances, right? But
yeah,
I've been taking those and I've been building musical scales out of them.
Wow.
So that I take each coefficient and I just use that as the frequency, and now I have an entirely different scale. But it is interesting, you'll see here in the 12, 440, you see that? 440 right there.
Right.
Good.
440, negative
440. Yeah, that's what most people are using as A today. And it happens to do with 12, which is the 12 tones of the scale.
Wow. Oh, and then, so if we were to look at like a 12-dimensional angle or something like 12,
I don't know what you would find.
right?
You're
You
not
couldn't
gonna
fi-
find.
you're not going to find a decent
Well, like,
geometrical.
how do we conceive of these things? You know.
I mean, they could do some sort of an origami thing, but it'd be physically difficult to conceive of the way we.
Perhaps not. Maybe well, I use these objects. So like, you can pull up. Go ahead, pull up the seashell. Are you on a Mac?
Yeah.
Okay, so you can look at it.
Where's the seashell? Is it back on the email?
It's
Go
that
back
way.
to the emails here.
Yeah.
Let's go Parker, and then is it this one here? Yeah. So these kinds of things. First off, this is not what you were talking about. There's another one. The
That is
seashell
the one.
tulip.
But I
Right.
use them as objects of visualization and meditation, and you can actually visualize rotating them.
It's interesting.
Visualize
Also,
rotating them, and then it will induce a kind of mystical experience.
this is what they make horns, horns and shells designed to make noises, and golden ratio, but also interesting that you called it the tulip because it's like a blossom, this golden ratio flower blossom, but the tulip is also Dutch for turban, right? So it's kind of like a turban wrap as well. And then what's this guy? The open torus. Oh, yeah. So there's a thing happening for the few of you watching where Parker is in the woods. And so sometimes his signal might drop out. So he's going to reconnect to us really quickly. While he's doing that, I'm going to go through some of these equations just a little bit. And the idea of 12 angle geometry while he's connecting back. So it's interesting because and we've done this before. We've talked a little bit about 10 dimensions. So let me pull up just to remind everybody 10 dimensions, how we've bothered to look at things before. There is a metric that you can use. It's the spheroid inside out, I think is the video, right? Turning a sphere inside out. I'll go to the video for you. This one here. And I'll just show you just a quick clip of it. So if you were to take a spheroid and you were to try to bend it, you'd have these creases, right? So in order to avoid having these creases, there's a way that you can fold it in, twist, and create 0 creases in the turning the sphere. But it requires essentially a plasmic split, right? I'll play that again. Watch this. So the sphere comes down, the pieces come in, they spin around each other, creating no tension point. This is geometrically the least amount of torsion that can be produced. And similarly, right, you can do the same thing with a rail system, which is how, let me push it a little further for us. Is this right? No, turning a sphere inside out? Okay. Yeah, here, imagine you're watching just a slice of the sphere. Okay, so the sphere itself, if you were to have a track, let's say it's not a sphere anymore. Let's say it's DNA. DNA has these clipping points, and anytime you have a clipping point, you actually lose a bit of data in the DNA. So how could you have a lack of loss in the data by not having a clipping point, right? If you were to do this, you create these 2 clipping points, and then you lose again. So the answer, I think they're going to show you in a second. I don't want to skip too far ahead. They're going to let you see some failed attempts. Here we go. I think right here. Imagine that you're on a train rail. Okay, here you go. Imagine you're on a train rail. This is the way to make sure you don't crash. It follows a multiple spiral, and it's similar to the gear system because you have with gears a certain amount of force versus a certain amount of distance pulled depending on the size of the gear. Also, this is 3 full turns to the left because if you have gears, they spin in counterclockwise directions. So having a trail, you can actually have a spring that allows it to make several directions that over the period compensate for each other. Negative turns 3, right? So we'll go a little bit further ahead. This is how many times it's going forward or going in a polar direction. And then beyond that, this is how far it's going the other direction. Okay. So there's a certain absolute value that adds up to equalize. Boom. All right. And then if you move it, there should be a few ways you can continue to add this. So 2 counterclockwise. Let's see here. Topographical map. Right. Same issue with canonical. In a canonical angle, you're going to have certain varying torsion. In order to compensate, you have to have equivalent torsion in the opposite direction, or have an accumulative amount of distance to force the torsion out, to use up the energy. Turning point number 1. So, I mean, imagine you do this to every single slice, right? And you imagine it's like a 3D printed spheroid. Each slice itself could have its own patterns, but they're going to have equivalent torsion above and below each other because they're stacked. So the stacked torsion is an essential part as well. Let's see. And here, okay, watch. Here's how you unfold the knot. And you've probably done this if you've ever had like a string and you've tried to tie a knot or untie a knot without letting go of your hands. If you've ever done that, it's like a fun experiment. But there you go. Here it comes, and boom. So each part of the torsion has to be broken down independently. And this is kind of funny because there's a story in the Buddha Bible where Ananda's talking to Siddhartha, and the Buddha says, if you had a silk handkerchief and you were to untie 5 knots in the silk handkerchief that were already there, how would you get rid of the 5 knots? And he was, Ananda says, you start with finding out how the knots were tied and doing the opposite and doing it in reverse, one by one, starting with the last until you get to the first. So there's a certain amount of energy that has to be broken out. Here we go. Simultaneous torsion. There's a breakage there, though, right? I think they're trying to say there's a reason why you can't. There you go. So then you can have a wobble. This is the best way. So if everything has a, what do they call that? The gyroid arctan, a gyroid arctan. I think that's what you call it. Then it will eventually force the torsion out. And some reason that I find this kind of relevant, I mean, it's interesting, but it's applicable if you're ever trying to 3D print and you're using really hot ABS plastic, like the plastics that are more serious. When they cool down, there's a lot of torsion in them and they'll bend. And you end up having these warping parts unless you have a really hot temperature that you can keep them at for a longer period of time as they're starting to settle. Keep it at like 40 centigrade at least for, an hour after printing, so that the torsion doesn't keep trying to work itself out. Whereas that's exactly what you use to straighten teeth with braces and memory wires, because memory wires also hold spring torsion as well, which can be stored literally with potential energy and heat. Oh, here's a good one. Let's watch this part right here. Should open even wider. Can you see that? And so DNA, but also amino acids, follow this idea. Amino acids have the same protein fold system that will wrap around and then they tighten. And so you get a full, so this is not outside of what nature does every moment. You've got this going on inside you right now in a lot of your amino acids that are being broken down into proteins and proteins that are being broken down into amino acids. The ATPs use a similar function as well to break down reality, just to make energy, right? So you have a certain amount of energy that's discharged, but you have more energy that's produced from the discharge. Oh, here's Parker. Yo, are you there? Can you hear me? Hello. It might have already frozen again, man. You might have to give it another shot. All right. Well, while he's trying to get that Someone says there's 22 base amino acids and 22 major arcana. Yeah, that's a very good point. Let's look at that. 22 amino acids. There's actually more, but there's some similar, very common structures that we experience. The 22. I mean, really, there are thousands of various ways a chain amino acid can exist, but there are common chains, and then there's a couple uncommon chains, and they can even be variously designed. But this is not as weird as they look. Look at an amino acid protein chain. So a protein chain will look like, well, it's not even, I mean, that's more what you get. You get these weird spring-loaded systems that will have a little bit of energy in them, and they're forcing the torsion, so they eventually want to straighten out. But they can't fully straighten out, so they continue to spring at each other, and you get these really cool ones. This is really what it should look like to you when you think of an amino acid and you think of a protein chain. The protein chain of amino acids looks like this. It has all these phone cord, like boogie board cords. They're just bouncing around. And because the peptide bond uses up a certain amount of ATPs in order to produce, energy, you have to have a certain amount of energy already in it. But because there's so much potential energy produced, I forget what the formula is, and we'll have to look it up, but it's something like 40 for 2 or something like that. You have 40 parts of energy for 2 parts of energy used. So it's a pretty valuable battery or generator or fuel cell, however you want to look at amino acids. Does it take anything from harmonic frequencies? Absolutely. And you can even see, I mean, this is a big thing about DNA. In the solfeggio frequencies. Can't spell solfeggio. Do this right. 2 G's. There we go. Solfeggio frequency, that we've done ample tests on harmonic frequencies, how things are held together. If you take sound away from, if you change the sound, if you change the frequencies, particularly, you can shatter and blow things up, which is the thing. Seem to freeze. I'm calling Parker. So you can tear apart, microwave ovens do this. And it's kind of interesting that the 2.4 gigahertz frequency for a long time before 5G freaked people out. 2.4 did, because water is activated 2.4, which is why they use it at microwaves. So you'd think if there was a frequency you didn't want to use, it'd be the thing that you're 75% of, but the other thing is there are positive frequencies, and this has been a big thing. So Parker, when he gets back, I hopefully will bring up more about time wave, Terence McKenna's time wave theory. Let's do this really quickly. McKenna time wave theory, zero, what's it called? Time wave zero, right? So imagine that he's not the only person to say this, and they've said it in better ways probably than McKenna did, but that there's been these peaks and these valleys in energy levels over the centuries. And if you were to map out, granted, he didn't use Fomenko, but if you were to, that's an even more ironic point here. You map out the highs and lows, you can find the energy peaks in humanity when things are better or things are worse. Here we go, Parker. There he is.
I apologize for that,
Oh man, did you control the weather? How dare you? What do you know? You can't control.
Butterfly controls the weather.
Right. Exactly. I don't think we have the power to and that was fine. We got to do a little thing on peptides while you were gone. We were explaining springs, but I'm gonna pull back up. We were at Conical. Oh, I wanted to ask you about torsion and
the Taurus.
I don't know. Do we start with the Taurus, or do we need a little bit of information about what torsion is? Because torsion is really interesting, because that's the thing. It controls so much potential.
If anything, I would warn people not to play with it.
Well, I was just saying, I use 3D printers, and the heat in the plastic will warp because of the
that kind of torsion.
Well, I mean, I think it's applicable. It's applicable on every level, because torsion has to do with how life works, how springs work, and everything. So, but you go into how dangerous it is to mess with torsion fields. That's not a bad place to start.
Well, like this one, you see, like,
Here, let me
So, like,
let me
now you
pull
can
my
play
screen
this
out.
Like I mean, there's
Show that
there's
again.
orgone, and torsion combined with this thing. It's
Pull
like,
that out. Show me that. Or what is this?
this is one of my equations that I 3D printed in steel.
Wow. So it kind of looks like a symbol or a UFO.
It's nice. Like,
Wow.
yeah, maybe it does have to do with UFOs. I don't know. It might.
That's pretty sweet. So wait,
You can
what
put
is
two
it?
together.
What did you make it for? What's the plan?
Oh, well, it was like a bell. I don't know. I'm experimenting. I'm just experimenting. But it's like a bell, you know.
Yeah.
Like,
I mean, it seems magical.
yeah, well, I mean, yeah, well. Electricity seems magical too.
Mathematics, man. People get so scared of the magic,
bread of
magic, right?
Ether, bread of heaven, you know, manna from the sky, manna of the cup. That's more I go that direction.
I feel like people, hopefully everyone here has already seen it, but if you haven't, you got to see Donald Duck in Math and Magic Land, where you learn how magic is math, and he goes deep into learning about Euclidean geometry. And yeah, of course, don't ever forget there is that, Pythagorean scene with his hand in the Masonic chessboard. But the point is, it's a great movie about math being science and science being magic. So nothing wrong with that.
Familiar with that now.
Oh, it's the greatest movie. It's 20 minutes long on YouTube. I'll make sure you guys all see it. But the torus, you have this picture of a multiple open torus, which looks like layered cakes of torus. What is this?
That's from, the difference between the circumferences of two circles, right? That is like an umbrella. You can fold up into a cone.
Okay, so canonical physics helps us understand how to turn spheroids inside out, or circles, to understand how circles work.
You get like how many variables, and you plot the contour of the height of the absolute value, and it's like complex analysis. So you take the difference between the circumferences of the two circles equaling an arc length of the original circle, not the second circle, but the first circle. And then you what do? You put the Pythagorean theorem in there, and then you get the height, and then you use complex analysis to have imaginary numbers, and you get this thing.
So with the imaginary numbers, are you able to predict like negative space or dark matter, or what are you looking for in the negative?
Dark matter. So this is where I really did want to talk about this, because they say, these galaxies are accelerating and all this stuff, but acceleration is the nature of distance in the height of the cone. So the height of the cone, and it's such a big topic. It's like, wow, like I've been studying this for 14 years, So
right,
I know
all this is a relativity. Speed is a relativity of distance and inertia, right? There's no way without. Yeah, exactly.
Well, I've almost just abandoned for light. Like, why do people think that light is a speed? It's like for light, it's like an 8-dimensional equation or something.
We've had some people that don't think light's a speed on here. Somebody said, I think it was Jeremiah, I don't know if he was saying he believed this for sure, or if he was just bringing it up as one of the theories out there, that light could be, and I know Aaron also brought this up, light could be explosions happening in a row, ducks in a row, and there's not that light's moving, but it's a chain reaction or something like that. That's been some people have suggested. Then it would be a connection between matter instead of just being a wave.
Transcendental language. I'm creating transcendental languages for people to make believe light can be whatever they want it to be in new forms that they discover. So
what do you think about light? Do you think it's corpuscular? Do you think Newton's right?
What do you my equations for light speed are probably 8-dimensional, 6-dimensional, and you can find them if you go to sphere of realization. Go to sphere of realization, and so the whole point here. Let me just go ahead. Liberation progression. One variable shouldn't be hinged to the other variables in the system. If you say that one variable in your system is the same as this other variable, you're going to get a paradox. So the more you realize that each thing is different from every other thing, then you're going to have less paradoxes, paradox reduction and amelioration. So we already went over using the phenomenological velocity as mental visualization objects for meditation.
I'm sorry, really quick. Do you hear that? There's like a.
That's my.
Oh, okay. No worries. But I see this thing: phenomenological velocity, V curvature equation, and discourse on the V curvature method as and energy as boundaries. So
Exactly. So like there is an infinite number of things that can't be infinity. There are infinite different, and those are the limits of your system. And that gets into creating like, well, what is consciousness anyway? What do we think we're perceiving here? And how is, I guess God, I believe God made it the way he made it because it works really well. And it is like this, but I'm also saying like, and I am saying like complex, reference frames they're computational reference frames for establishing a being. And so when the computer solves everything, it says this can't be equal to 0. But right. when I interpret it, I say that can't be equal to infinity because I'm counting back from infinity. I'm not counting forward from 0. When you collapse the cone all the way up, by the time you would get to where you would have gone around one whole cycle, the variables that you were, the parameters that you were using to discuss that system, they vanished. They're all gone. They don't even exist anymore. So by the time you would have gone all the way around, the very things you were using to talk about going all the way around don't exist. They've collapsed into the umbrella shape.
I like this because it's like it's revolutions instead of nothingness.
But but then there's a synchronous system to that. And that's if you say the difference between the circumferences of the two circles equals an arc length of the subtrahend circle. That circle which is then they're difficult things to talk about, but that circumference which is subtracted from the minuend circle, the one that gets smaller, subtrahend, minuend, those are the terms. But that one would go around for infinity. That one would spiral around infinitely. So imagine you're like way, way far out, right? So you're infinitely far away. Now imagine there's an infinitesimal spiral here, and where they balance, that's oneness. And in Aramaic, the language Jesus spoke, religion meant balance. That was the word for religion, was balance. How do you find your balance? So
man,
that's knowledge I've acquired. I've acquired this knowledge from the ancient Aramaic prayer of Jesus. So
I've noticed that and that's an amazing something I've been coming up with a lot. I really like the closer to the original translations as much as possible because it's so much deeper, talking about the creator of the cosmos, etc. It's weird how reductionary the translations have gotten. But something I thought was interesting was we've been seeing all this orbital stuff recently, right? And so I studied orbitals mainly. I took astronomy, we had a good telescope and all that, but the orbitals, P2 orbitals, looking at nanotechnology, small orbitals are very important. And I noticed at the same time that CERN gets turned back on, right? Everyone's all like CERN, because how could you not be wondering about CERN? You've got all these pictures from the James Webb Space Telescope of orbitals and things that really, to me, if I were to take a really small nanoscopic SEM or an atomic force microscope and try to look at things, on a very small scale, it looks a lot like this, right? Like these particular pieces that are all around. So it seems like the macrocosm and the microcosms are they're fractal. They're very symmetrically fractalized, similar in design. And
Well,
we're
yeah.
seeing that by looking at smaller things and at bigger things that there's a relationship.
True. But that's why my calculus wants to start from infinity.
Right.
I don't want to start from zero with my calculus. I want to start from infinity. It works well for fractals. I think it will work well for fractals if people work on it. Like, I'm the only one working on this branch. And I'm trying to find other people who want to work on it. But I mean, I'm not really into academia. I had to kind of reject academia. Had to go back to the woods, grow food, grow apples. That's what I do now. And yeah, so.
Yeah, it's crazy. You've got this other. I'm gonna open this one as well. Hold on, let me reload the page now that I'm logged into the thing. She'll let me.
But there are different meanings of infinity. That's one of my main insights now. Is that yes, there is the one great infinity that we can't conceive of, and there are all the different kinds of dimensions. So, like, I have different kinds of dimensions. For me, angle is a dimension. It's a kind of dimension. For me, distance is a kind of dimension. For me, the embedded phenomenological velocity is a hidden dimension. It's an algebraic dimension, and you can see it here. Yeah, you're going right down into it.
Yeah, they're relative. It's an interesting concept, the idea that they're relative, because you can't really have speed without it.
Cancels out with itself. And I'm interrupting you. I'm sorry.
No. I'm agreeing with you. I think you're onto something here.
Okay, it can't. Just because something cancels out with itself doesn't mean you can't find a solution for it.
Right. Even though they're set to zero, they could be set to equivalent without thinking of it as nothing. It could be thought of as something.
And all of these algebraic manipulations are totally legal. Like, they're perfectly legal as far as I can tell. And I've done a lot of extensive analysis of it. And you can manipulate the variables in this way where you can factor out those so you can factor out 8. You can factor out 8 to get 9, and then you can put the Lorentz coefficient in there in such a way that it ought to cancel out with itself. So when we talk about the judgment, the normative judgment, you can cancel it out, or you can expand it. There you can come to motion, or you can go to repose. And if you look at the Gnostic gospel, it says, what's the sign of your Father in you? Well, motion and repose. We can expand and we can collapse. So that's my beautiful statement right there.
Yeah.
It's the most simplistic statement I found to date. Alpha equals E to the negative 2C over Q times QS. That's it. Yeah.
So elaborate. So alpha.
And this is for the speed of light. That's a four-dimensional equation for the speed of light. Or no, 5-dimensional, 6-dimensional right there. And those are arc lengths. One of the problems I run into in graphing and visualizing some of this stuff is that these arc length variables have to get flattened out in a box. But that's not really what I want. I'd like to be able to visualize them as the actual curves that they are.
Power, infinite expression, 1 over 0 encountered. Infinity, indeterminate expression, complex infinity of E.
Those are things that happen. And Mathematicus is very mysterious sometimes. People think, it's just so obvious, but no. Sometimes it's all computers are weird and mysterious, and they have ghosts in them and stuff. And
Venice Beach Dub Club says, when you guys talk about dimensions, does that directly equate to geometric planes?
Okay, what is his question?
So he says, when you guys talk about, quote, dimensions, does that directly equate to geometric planes?
Okay. Can I say this again? I wasn't done delineating the kinds of dimensions that there are.
Yeah, let's elaborate. Great.
So distance, angle, number, hidden dimension, which is the phenomenological velocity, curvature, number. Did I say number? Oh, mass. Mass is a kind of dimension.
Mm-hmm.
And then algorithm is actually a kind of dimension.
How is algorithm a kind of dimension?
Algorithm is a kind of dimension because you think about this, right? The idea, and there's such big ideas.
Oh, living numbers like Mendelbrot. Okay.
Oh wow, living numbers. Yeah, we could get into that too, but moreover, like no. What
No,
I'm
but keep going. I'm sorry.
okay. When I say this can't be equal to 0, so like because the number of things that can't be equal to infinity, there's an actual algorithm that goes and sets and says, hey, this can't be equal to infinity. This can be equal to infinity. These are the and that's a dimension.
Would you say then that not being something that can't be the encompassing all of an infinity would represent a dimension in a more general statement, or is that a little bit too broad?
Something that, excuse me?
It's something that's not infinite. Does that is anything not infinite represent a dimension?
Well, the infinite number of those things is an infinite dimension.
Okay.
Yeah.
So I mean, these are attributes. These are ways of qualifying.
They're attributes, yeah.
Yeah, but they're relative to each other. They can't really. You can't have mass without proportion, or you have to have a relative. Is that wrong? You don't think so?
Well, and at the end of the day, is any of this any good for describing the mystery of the cosmos at all? It's like maybe, yeah, kind of, sort of. Sometimes. I don't know.
Fair. Okay, here I'm seeing this warped curvature here, and so what are we looking at here?
Oh, well, can you go?
Yeah.
Can you go back to the? Because if I could show you here, yeah, maybe I can. Maybe I can just pull it up right here. Here, I'll show you.
Sure, yeah, and you can share screens as well, obviously.
Oh, no.
If you got it, flaunt it. Venice Beach says, okay. Another one, trying to understand, can these dimensions, geometric or not, be visually expressed as shapes or motion trajectories or something? Can they be expressed?
Mm-hmm. Go to dimensional fabrication. Did I sent you dimensional fabrication?
Hidden dimensions of the Lorentz curve, high accelerating point, difference algebra implicit, phenomenal warping.
Oh yeah, that's manifold warping. Okay, but
of eternity. I don't know. Dimensional fabrication. We're good.
Dimensional fabrication. Okay. I can't, and the ideas are so complicated, and I'm getting so old, I can't keep them all in my head all the time and write them down for people, and then other people got to go look at them and figure out what I was trying to say.
Propane. Well, this looks pretty good. What about this? I mean,
okay, can you go up one though? I'm going to try to explain what this is.
Sure. Is this good or further?
Oh yeah. So like, okay, if I do an algebraic manipulation and I multiply one angle, this angle right there, see H alpha? H alpha, there is no thing in the diagram called that is H alpha. But I can fabricate it, I can make it up. So, and I can keep doing that. And I could keep doing that out forever. But instead of having...
Oh no, he's frozen. All right, well, while he's frozen, because that's fun, let's look at this H alpha equation for a second. Okay, so what's it say? Premise of an algebraic geometric linguistic notation representing 3 delineated arc lengths and diagrams of arbitrary radius and arc length. And so the visualization of this solve will be multiple geometric triangulations, which create triangles, but also trapezoids. And on top of them, you have depths that are being registered, and you can represent them in all sorts of visual ways, I would say. So you can represent things however you want. And you'll notice that if I were to take like an AFM, atomic force microscopy, it's not a picture. It's like it's a bunch of indexes that you get. So, here's something, but let's say like index or something. You'll see something like this, right? Oh man, let me show you, please. How about that? They just want me to take. All right, that's fine. I'll do it. I'll download the picture. Okay, so when you open this up, dude, really? It won't let me just like open the page here. There we go. Okay, so you're gonna see, this might have been the item, but the item you can't actually see. Like it's super close up, but you can only see like the gradient of how the stoichiometric data. So here it says, hey, the stoichiometric data when measured at these distances, we found at, a major response at, 400 to 500, and there's a super absorption at 530 nanometers par density photoactive radiation. So from there, it started to grow back out again, but that means that there's a peak of some sort of a material that is reacting to nature at 530 nanometers, right? And you can pick that up with infrared, or you can pick that up with atomic force microscopy using different kinds of atoms that are bombarding over things. So you can measure, but the idea of seeing it the way it is, that's a more complicated thing. I would say the best thing to do is try to use, again, we're talking about relationships. So time, for instance, time as a dimension is map. Let's see, is there a map? So I'm going to do a map. You can do something like this, right? Timeline, right? Here's time here. Here's time there. Beginning of timeline. And they're saying here, granted, this is their own map, and they weren't there from the beginning. They won't be here for the end of it. But in their version of it, there's a quantum singularity, which is being considered some sort of a big bang, right? And then there is an expansion, and you're saying, hey, it expands more and more distance between these parts, while some of these parts are getting closer and closer together, right? Swarming together. And their story goes that they get to this, right? And this map is it's a representation, right? It doesn't necessarily mean that it's an accurate one, but it is the best one you have for that kind of time. Does this extra dimensional math have existing engineering applications, or is it purely theoretical? Absolutely, right? So in general, you can imagine Nile flood algebra, which is some of the earliest algebra that they use for the flooding of the Nile. And they would use these chart systems and infrastructures, and they could tell you exactly when storms were coming because of when snow melt was happening in Ethiopia. And then they could tell you when Ethiopian snow melt was happening from when the floods happened the year before. And they're able to predict this better than our weather meteorologists today using flood math. So there's a lot of actual value of time metrics, and using whatever metrics you have to say, okay, well, there's this huge amount of distance that's going to be affected by this. And they use, let's see, the Nile flood measure Nilometer, the Nilometer. This room, the Nilometer, would measure the flood season. And they would use these numbers every year to tell themselves predictions. And from there, they could say, okay, well, there's not an infinite chance of flooding. There's a predictable chance. And so we should be prepared for it. Hey, what up, man?
Hi.
So we just did Nilometers while you were gone, talking about the ancient Egyptians' flood metrics, because I'll be honest, I wasn't going to be completely right on your equation. So I figured I'd let you do that one. Let's see, where was this? It's the... here we go. Dimensional fabrication. You were here. You were looking at H of alpha, I believe.
Right.
See, I pay attention.
So, but like sometimes, like there are these very abstract ideas, right? And so, like I might have an epiphany or an insight that gets me to be able to write down one of these things, but after that, it's just kind of gone.
So oh man, you're gonna get frozen again, huh? Everybody pray for Parker. If you're frozen, come back. I'm gonna want to ask you that same question that Venice Beach asked me. Does this extra dimensional math have existing engineering applications? More specifically, I'm gonna ask, and I know you can't hear me, but it's just too funny not to ask you twice. What your applicational goals are for this? Yeah, that's what you guys want me to ask him. Cool. All right. So Nilometer. Who doesn't love the Nilometer? That's a great thing right there. So Nilometer can measure actually the flood seasons. There's another thing we were going to measure. So sp2 orbitals and the I mentioned earlier, Kovsky reaction. It's not spelled the normal way. I'm pretty sure. Chemistry. Is this it? Tchaikovsky. That's why I was like, I know it's wrong somehow, but you know what? That's fine. Here we go. So the Tchaikovsky reaction, this is what I was talking about earlier, what I said, you look at this and you say, what are you looking at? Okay. But one more thing, football play book. You know, you ever watch Waterboy and they have these like plays and they show you how this works? This is literally the same thing. This map will tell you what, and imagine how random football could be. In fact, football is less and less random the more organized the team is. So the same as the military, but you have predictabilities based on size that you have to assume from the other team. You're like, they're going to do this, so I have to do that. Our reactions have to be the most strong reactions to they have to be the correct reactions in weight, mass, and inertia, right? There's all kinds of rules in football. I don't even like football, man. I mean, I'm not hating it, but it's like, I've just noticed its chemistry and it's really impressive to me. So the Johnson-Corey-Tchaikovsky reaction, otherwise known as the Tchaikovsky reaction, is a chemical reaction used in organic chemistry for the synthesis of epoxides, azardines, and cyclopropanes. It was discovered in 1961 by William Johnson and developed significantly by E.J. Corey and Michael Tchaikovsky. See how his name's not there? This is why it's important. Like, I tell you what, he's the guy who did the work, and you're never going to hear about his name. It's terrible. The reaction involves the addition of a sulfur halide to a ketone, a aldehyde amine, or an enone to produce the corresponding three-membered ring. The reaction is a diastereoselective, favoring trans substitution in the product regardless of the initial stereochemistry. The synthesis of epoxides via this method serves as an important retrosynthetic alternative to the traditional epoxide reaction of olefins. All right, and so epoxide is a cycle where you get a generic epoxide looks like this. It's a very stable molecule, and you can use it in bonds. So it's epoxies, but also in pills. They use this in all kinds of things to hold shellac together. Ethylene oxide, it's a very functional group. It'll hold on to something pretty well. So there's a reason why we make that material with plastics, because plastics use lipidic oils, and we couldn't even know that if it weren't for the fact that we've digested so many plants and so many animals that have lipidic oils in them that eventually we started noticing it in our own diet. But there were people making waxy plastics long before this, and you can look at rayon is my favorite plastic in a weird way. Rayon is not a polymer. It is a cellulose. It was very popular in the 1818, whatever, to 1860s. Early rayon disintegrated very quickly because it was biodegradable, the same as your rolling papers made of cellulose were. So these kinds of discoveries happened mainly because they were able to figure out ways of mapping. They're like, okay, so what do we got here? Well, we have a bunch of oxygen hydrogens that are connected to some salts. We better connect the chlorine and the nitrogen, and the sodiums, and we have to figure out exactly. And so they drew this up. They're like, what's happening here? And they were able to build up essentially a football play that's pretty legit. So yeah, I mean, that's one of the reasons and one of the ways that this is theoretically really valuable. If you like your cellulose rolling papers, then you've already probably found value in chemistry and plastics. Okay, but then there's sp2 orbitals, which are really fascinating, because then you're like, what are these things? Okay, let's get back really quickly because he's here. So Parker, the question he asked was, does this extra dimensional math have existing engineering applications, or is it purely theoretical? What are the uses for you for this thing?
That's like a great question. I think we're seeing, like, you see those tulip wind shape things. I think yes, it does have applications. Combining with other technologies, these forms, that would be really important. But I hesitate to experiment with any technology. It's just not what I think people should be doing. I don't even like the Hadron Collider or any of that. I mean, I think I've discovered more about light.
Oh man, they really want to shut this guy down. It's the Illuminati trying to stop him. I'm telling you what. So I can riff off that though. The deal the thing is that if you have technology, it can hurt people, and that's a fact, right? So if you invent something that's able to use this technology for good, it also means it could be used for evil. I imagine it will be used for good, but my first thought is this could be used in physics experiments. Let me show you a non-Euclidean geometry video game engine. Oops, I shouldn't have closed that. I'll keep that thing open. But Is this the right one? So this was really fascinating. This dude created a video game engine using these non-Euclidean rules, right? And the way it works is that none of the rules in nature are real. So you go through this thing and it's a lot longer on one side than it is on the other side, right? It's very short if you walk through this side. It's very long through you walk through the other side. He's done all kinds of things like this where, going down might be bringing you uphill, for instance, is another one. Or inside, there's multiple rooms. Each room has multiple walls. Each wall has multiple dimensions of space and distance when you're standing on it versus when you're crawling up it, when you're going in one direction versus another direction. These kinds of experiments that are able to help you learn about different kinds of depth and dimensional perception, maybe that will lead to us being able to see things in new ways and being able to process new ideas. For instance, you go through a tunnel, it takes a certain amount of time in your day, in your video game day. In Grand Theft Auto, the day goes certain speed at a certain way, or, moments are connected. You go through a tunnel and you portal back to another moment. That's really big in games right now. So there are some virtual ideas that could be very practical for this as well. I like this one. This is fun. You walk around the thing and then it's in another room. In this room, there's a monkey head. But if you walk through this room, then it's so going around the pole takes you into a completely different space, and they can do that in different ways. But okay, so we were going to, let's just watch this for a little bit longer. The downhill thing, and he goes back up the hill, super vaporwave, right? I want to play this game. Somebody tell this guy to release this in Steam so you can do this. It's super sweet. Okay, but the sp2 orbitals I do want to get to also. Just throws that. So sp2 orbitals are really interesting because the bonds that they produce and they're necessary to form, if there's not one, it's going to form in nature naturally. And we didn't know that until maybe 30 years ago. So that's how we're able to predict that graphene could exist. That's a major thing for me, right? Is I produced graphene. I went to school to do laser ablation to produce graphene. And we found that carbon hexane, it's actually able to be non-polar, and it can be neutral, and it can reverse, which means it can be inert, and it can be used in medicines, and it can feel. Keenan's like, this feels like Turok. It does, right? That's. I agree. This is like Turok kind of. I like Turok, but it's like Portal. Is the way I think he was thinking. Portal should have this more. Portal comes out the other side. How crazy is that? But you can use these. That's another example. The Buckminster fullerene. When the Buckminster fullerene was discovered. Oh, here we go. Well, another story for that time. Parker. So we shouldn't use it for evil. The Hadron Collider is dangerous. Keep going.
No. Oh, no. I think we need to use our minds more and stop bashing rocks together to see what. I also don't. I think the premise that you can use a material thing to discover or have realization about some other material thing, I think that's logically flawed. I think you have to have if we want to exceed the quote function of light within our reference frame, our computational reference frame, we need to have a different, we need to have a more liberated formula, have a more liberated formula for light or whatever, or our perception of what light, or our belief about what light is. So it really comes from consciousness, more understanding the material realm. I think it's tautology. If you use matter to believe your understanding about something about light, then you're going to have a matter-based understanding about what you think about light. Because that's what you're using. So to think that you've understood something about light because you used a material instrument to detect something about light, I think that's flawed. I just think the premise is flawed.
So many people argue about particle wave duality. What do you think? I mean, the Boyle, Lockean corpuscularianism is this idea, right, that light has particular matter to it. Do you believe that there's something true to that, or are we missing the point? He's thinking or frozen. You never know. Well, I'm gonna go back to sp2 orbitals for a second then. Where were we? Oh yeah, Buckminster fullerenes. This is great. No, I have a story. So there's these guys in a laboratory, and we've already heard the Santa Cruz kids who did the graphene one using Scotch tape. That's not really true, by the way. They were using like super refined carbon graphite, and they were using 3M science adhesion material. It's not quite the Scotch tape thing, but they did have another interesting breakthrough where they heated up a bunch of stuff. They just burned, and let's look at a picture of like nanoscopic. Oh no, SEM sand. There you go. Look at this a scanning electron microscope picture of sand, and you see these are the kind of things. Now, how about sea life or whatever? Sea. There we go. These sea shapes. Okay, so when they started doing it in California, right, and we're by the ocean, we see all these crazy things in the sand at the beach. Pretty sweet. And last cue, beyond engineering, how can you know if the math reflects reality? I'd argue that the experimentation is insufficient proof of understanding. Based. Okay, so this is the other side of it, right? Is that we're taking physical objects that we're finding and trying to describe them. I swear it's going to make sense. So these things are crazy looking, right? But it makes in your mind, you're like, yeah, the ocean, sure. There's going to be these crazy things that are emerging from the ocean, but some of these shapes are just incredible, and they're geometric, brilliant shapes that are showing these same mathematical patterns. If we were to try to reproduce them, the same. Now I use 3D printers. You can do it in other ways. The way these things are growing, you're doing the same thing. You have a Mandelbrot fractal pattern. Mandelbrot is a great example. As he found living math sets. Now they look cool, and when you zoom in, you see more of them, and that's great. But the reason it matters is, let's say you're a farmer, right? And a farmer goes out to trade some sheep for some lamb, or for some fruit or something. So goes to an orchard, and he looks at the orchard, and he sees one of the, in the center of the field, there's a tree. So he goes to the center tree, and he measures how tall that tree is, how long the branch is, and how many fruit are on that tree. And from that tree, he's able to tell how many trees there are in the entire field, how big the field is based on the length of that branch, and how many fruit the other trees will have in general based on that tree. There's a certain amount of fractal patterns. It's not exactly the same number, but there is a pattern there. And how accurate is this? Well, farmers would do speculation trading for thousands of years, and still do, where they're going to pick up a sheep and they're going to base their trade on how that sheep is to the rest of the litter, as well as the other farmer looking at how that fruit compares to the rest of the orchard based on speculation. So there's a huge repetition, and it has been for thousands of years, in patterns emerging that are usable to actually make real life decisions. And that's important. Furthermore, you can take a fruit from one place and plant it somewhere else, and you can even predict how big it'll grow the field around it. So Johnny Appleseed, totally predictable using fractal Mandelbrot math. Okay, now we're looking at these shapes. We're super impressed. We're trying to figure out how we're going to build graphene nanotechnology that's better than nature, and we're losing it because we're like, whoa, look at nature makes its own Velcro, hooks and loops. This is just, it's out of control. So finally they come up with this thing that they burn a bunch of stuff. Let me go back to it. The Buckminster fullerene. How far back do I have to go? Where is that? Buckminster fullerene emerges. They burn a bunch of stuff, and one of the shapes that naturally occurs out of the carbon is a Buckminster fullerene. And they say, what is this? How did they get it? And then they measure it and they take it to labs, and the guy finally says, well, you know what? I got a lot of ways I could explain this to you. You can call it a Buckminster fullerene. You can say it's a dodecahedron. You could say it's some sort of a geodesic shape, or you could call it a soccer ball. And that's the point. Is it occurs in nature. Hey, Parker's back. What's up, Parker? Or is he? Parker, you might be frozen again. Oh, man. We might have to do another one with Parker where we get him like a better signal situation with some SpaceX. 'Cause I do like the research he's doing. It's pretty sweet. He's got this research going on. But okay, so they realize that a soccer ball has the exact same qualities, and they were like, yeah, we're not actually as impressive and clever as we are. Nature, it's just something that happens. These shapes make sense, and so they happen. And as you start to build that up, you realize that shapes and algorithms, it's a more subtle thing. Like, we're able to pick up on the shape of a soccer ball. You might not be able to pick up in the shape of a rise and fall of an empire very easily in one lifetime. But let's say your family have lived in an empire for every generation, and they have these diaries and journals. You might have a very specific look at it, especially if you could compare it to other examples of other empires, and you could create in your mind a milieu of shape that you could gestalt, you call it, that you could compare, right? And that came up with Nina. I think we talked about Gerd Chief Enneagram. And so Gurdjieff had done these kinds of studies on personalities, right? And found that there's actually a food octave, and there's a health octave, and there's a way people interact with each other based on if there are challengers or they're testers, right? Or if they are peacekeepers, or if they're whatever. So people have harmonic frequencies where they range around each other, and it seems to be the case. Some people like to call it other things. They're like, oh, well, this guy's an alpha, or those guys are just followers. Or no, I mean, it's a lot more subtle than that. People are leaders in their own ways, and people are followers in their own ways. But really what they're doing is they're trying to organize a harmony. At least it seems like that harmonies emerge, because in nature we find things like jade, geology. Jade is not normal. Jade is a miracle, right? Jade is, you don't just find sand, you don't just find atomic sand. You find atomic precious stone, right? Glassy stones. And the way glass stone has to emerge means certain kinds of bonds that are just so articulate. Let's see if we can do a jade bond. They'll show us any picture. The pictures, they're so articulate, the way stones will form and coalesce, that it's not random. It's a perfect symmetry. It's the only way it can be so clear, so glassy. It's their perfect symmetry. And that's amazing. It's almost impossible for us to replicate that kind of perfection of symmetry. So nature having perfection of symmetry, it's something that we need to understand. How is it possible that so many things come into forms, coalesce into harmonies, right? And harmony is I think the most important word here. This is also pretty crazy. Jade coming out of a volcano, because as you know, pressures pushing jade out of volcanoes. That's clearly what's going on. But jade's, I don't know. Jade is the most ancient, valuable material of China, more valuable than gold. They used to have these Chinese dog tags that you'd wear around your neck like this. You'd have a little ring, and your family would bring it home to you if you died. Very strange to wear a jade disc around your chest, right? So there's that. I don't know though. You want to know if there's things you can do with time travel, meteorology, difference equations. I mean, I'm sure that that's the next level, is measuring how fifth dimensional strings work. So 5 dimension. Once you start to imagine the idea that there could be simultaneous existing spaces, the way that you can exist in the past and in the future at the same time, because you're alive, right? So that's a pretty impressive thing people don't think about. The person who's being here now is both in the past and in the future simultaneously. Like, if you were to be in the past right now, or someone were to be and to look for you, you would be there. It's impressive. And then the future, up until you're not, you're into a point in the future. So you could say that's crazy or that's not relevant, but it really does come down to this idea that you're existing in multiple spaces at the same time. You're not fully aware because you are different. And that's one thing that we've also said is there's a difference in the singularity. You're not the same person one day to the next. We tried to dismiss that. But there's a phenomena there that's worth exploring. So if we're able to have choice, which seems like the main idea, then it means there's convergence of symmetries that you're existing in. That might mean that you're existing in multiple realities at once, the same way you're existing in multiple times at once, theoretically, right? Because you're, again, one person in many times. So if you're out in if you're in multiple strings of choices, it also explains quantum shifts and explains variable reality shifting, the Mandela effect, I like to say. Yeah, tell Scott Bakula it's not relevant. God, we need just obligatory quantum leap picture right now. Interestingly enough, I went to watch Quantum Leap on Amazon and it's missing episodes. I don't know what that's about. I went and I found them. The one that was missing was where he has to save a stunt double. Well, he's a disco player. That was pretty much a terrible thing. But man, quantum leaping is real, right? This is the most important show. I spend most of the time whenever I'm watching a show wondering why it's not Quantum Leap. You know, I saw the Thor movie recently. I'll tell you what, the Thor movie, it's amazing. I never watched it before. Elves. Dude, the Dark Elves. Look at the Dark Elves. So the Thor movie, they have this light cannon that they shoot themselves out of the sky like laser beams, which is literally my whole thing. The Li-Fi gods that are seeding the earth by using a light cannon. And these are the bad guys who use ether and live off dark matter. And they have these gnarly, stoic, Lord of the Rings-esque, granted. But, I mean, also, I think this is 2013 or whatever. So isn't it before Squid Games and everything else? It's more like Legend, right? It's like a Ridley Scott thing going on. But these are the Clockwork Elves. These are the DMT Clockwork Elves. And for the first time ever, you see a movie that actually presents them as not like, I mean, not the first time ever for sure, but they're not presented as like the good guys. I mean, a lot of people are like, oh yeah, Clockwork Elves, we should all do DMT. No, man, look at these people. This is what you got to be scared of this. You don't want to have the Clockwork Elves taking you with their dark ether. That's horrible. So I don't know. The Thor movie, weirdly realistic. Where's the Thor light cannon thing? It had like, I can't even remember what it's called, but he puts a giant key. It's like a sword. It's a key. And then it, light bridge, rainbow bridge. How about that? A rainbow bridge. Okay. So the rainbow bridge is pretty cool. I'm down. But this thing at the end of the bridge is a light cannon that aims at different solar systems or whatever and shoots the gods out as light beams into the world. If that's not literally the Dyson sphere thing, I mean, I don't know what is. Also, this is way cooler. Why didn't they do it better? It could have been like this. The rainbow bridge they use isn't all curvy and fun. So that was a real bummer. I think they should have fixed it. Well, let me check again. Crepuscularism is the thing that I kind of wanted to hear what he had to say about, but you guys know crepuscularism is this idea of particle wave duality having actual particles. Atomism, the idea that light itself has atoms to it. So let's do an image search. Oops, go back. Little bodies. And you'll see examples here of Mondo by Botic. I don't know. Not a lot of great pictures. I saw another one earlier, though. Crepuscule. This is physical crepuscules, though, right? Yeah. So definitely connected to the idea of cancers, they're saying, little bodies, which is interesting that they've taken it to mean cancers. That's strange. What does that make you think? All right. Going back to sacred geometry, multiple dimensions. Let's do a 12 dimensions. Physics. What do we got? I also got to get Harut on at some point. He does 12-dimensional physics and 12 base math, which is very useful. I don't know. Pull open the... We got here, finding meaning. A lot of these ideas are 12 dimensions of wellness. I see that. How about 11 dimensions? Because 0 counts with infinity. What do we got there? MLT. History of string theory timeline. Yeah. I don't know. Well, I don't know, man. It might be that I'm gonna give him another shot to show up, but if his internet's down, we might just do a reschedule. But there was some good stuff there, actually. Looking into the hidden dimension collection of the Lorentz coefficient. Maybe I'll open this up really quickly. We'll see what this looks like. I didn't get all of his papers. He's got a lot of good papers, and I'll have links to these so you guys can check them out because some of you I know do like math. So. Abstract. While this is certainly not all of my research on the topic, this assembles those sections of my research that pertain to the hidden dimension V curvature phenomenological velocity, essentially where we factor out certain algebraic forms resulting from difference equations and circumferences of two circles or difference between two arc lengths and apply the Lorentz coefficient in such a way that it ought to cancel out with itself when using the exact speed of light in scientific notation. A resulting formula from the V variable phenomenological velocity within the Lorentz coefficient results. Mysteriously, yes, but the pathway for the solution is also delineated within. Okay. So, I mean, I like this idea of trying to root a fractal. And because you can't get a full root of a fractal because it's an infinite concept, that you have to just write a formula that you can compensate for that. And then that makes a lot more sense than trying to set numbers to zero, which is in school. What they do is they tell you set everything to zero. And it makes sense to know how to do that. But this is a lot more interesting because if you're creating a coefficient around a fractal pattern, it's more, it's a potential imaginary number. It's an algorithm that can be generated and it can be changed at any point, but you can still do math with it, even if you're not sure of the exact value. Or if you are. Are the green emerald tablets an actual form of gold in its monatomic state? Well, I don't have access to the tablets, so I probably wouldn't be able to find out. That's a great point. In terms of that, I would say monoatomic gold, for those of you who don't know, it sounds like you do, is that there's a lot of different colors that gold can be. If it lets me look it up, that would be sweet. We're going to load internet. Monoatomic gold. Do it. Well, nanodots. How about this? I'll type gold. Is it freezing on me? Gold nanodots. Something should pull up. So basically, what you're seeing is the refraction of light off of things, as far as I'm told. And maybe corpuscles are more real than that. I'd love them to be. But the idea is that gold can be sputtered. So let's say you take a paintbrush and you're spraying the mirror of your bathroom with the toothpaste from your paintbrush or your toothbrush. There you go. It's just sputtering is my point here. You're getting a small amount of material on a thin film instead of on a mirror. It's going to be on a piece of film, and you use sputtering to get a smaller and smaller amount of material. If you sputter it and then you shatter it and sputter it again, it breaks the particle down even smaller. And the smaller it is, the lower the par density. I don't know why this won't open. I don't know what I've done wrong. I don't know why it hates me. Come on, internet. Don't fail me now. Do I have to go to Google? Is that what they want from me? It doesn't matter. I don't even care. So I'll just tell you. So gold par density is, I think, at 280 to 300. Look it up. Nanometers par density, PAR density. I was going to look it up. It's not letting me. But you can look it up, and what you'll find is par density changes depending on the size of the particle. So if you have gold and the Mayans used to take gold and sputter it, like I said, with a brush, and then they'd get it in smaller and smaller until they had such small pieces of gold that they were pink, or that they were green, or that they were blue gold. I've seen blue gold. It exists. And all it takes is the particles being so small. And then they put it into a glass of water, and you can have blue dots, which are impossible to see unless you have a huge accumulation of them, right? So this huge accumulation could also rebond together, and you would lose that quality. So it's all about the special way that the particles are sized, right? I think that's basically my point. There was another one. Extra. If You is an observation. Can it truly exist in more than one point in time space? I'd guess omniscient means being not seeing all points. Well, like omniscience or omniscience, or do you mean like omnipresence? Because that's the other thing, is we're probably part of this thing. But yeah, if we're not able to know what's going on, are you you? What is you? Which part of you is you? Why are you not aware of everything going on around you? Do you need to be aware of everything about yourself to be yourself? These are great philosophical questions. I don't know. I would say that you don't need to be aware of everything about yourself to be yourself, but that being yourself means knowing thyself. And so you kind of win that one. I wouldn't imagine that it matters, because the point isn't really about your soul in that respect. It's more about the physical symmetry at that point. But it might matter. If it did, that'd be interesting. I mean, how much you making the right choice affects other versions of you and other realities, that would be interesting. I don't know if I'd say that it doesn't, but the idea is, I like better that your choices affect you, the part of you right now. There are parts that you are not in control of, but you're paying your own bill. So who's to say? I don't know, though. I don't know. I mean, my favorite is when you talk to the sciencey guys and you say, hey, in this own reality, according to your own Drake equation, there should be other people just like you, regardless, because you're such a logical thing to happen. So, I mean, this is such a logical thing to happen. Earth must be a logical, scientific, atheistic thing to happen. If you think that's the way it is, then there should be plenty of you. So no one's able to come to odds with that yet. Ego, divine spark, you, soul, collection of experiences, spirit, similar to astral body, but operates in spiritual realm. These are concepts from the light of Egypt. Yeah, I mean, the idea that the Egyptians also said that you had a separate soul. Your Ka is separate. There's an exterior part of you, an exterior soul. You're not just yourself. And, even the fact that you come out of your family, you didn't exist and you do after that, and then you stop existing, but your family continues to, hopefully, that says something about who you are and what you don't know about yourself. So, and yes, black mold can make you depressed. Avoid black mold. Clean up your homes, get bleachy water, and just fix that. VB says, if you are conscious in other realities, then that means time is not a geometric coordinate, but something that supersedes dimensions. Maybe it's its own dimension of distance, because you have this idea of arrangement. So he's talking about algorithms. So this moment is all the same stuff from the other moment, but it's arranged differently, right? So, but theoretically, that stuff's still there, and it's even still happening there. So the difference is only where it's at right now. So things aren't that different moment to moment, but they're hugely different in subtle ways. It seems like that's why you can't know about your future the same way, but you can kind of have measurement of your past to an extent, because you can kind of you've gone through it already. It's not that your past is as distant as your future in a sense, which is interesting as well. Well, this is pretty highbrow for a Sunday. Let's see. Tomorrow I've got another guy coming. Forget who. Tuesday is going to be fun. I mean, that should be kind of a secret, but in the evening, there's less of a secret. There's 2 shows Tuesday, but the evening show is Sync Tank. I'm creating a new show, Sync Tank, and I'm just kind of like, every day is a weird day, and just celebrate it like it's an Exertus holiday. So Sync Tank's going to have Alan Green, Abadessa, and David MK Ultra Sound Plate will be here, and it'll be kind of more on the weirder level. I'm trying to get weirder and weirder stuff because people like that. And then I'm going to also start to have some more normal, serious people, some no nonsense people back and forth, because heterodoxy is where you have the exact opposite things, and from that, truth comes out. And I think that's going to be good. Another one, VBD says, if another me dies and I continue observing that not me in any way I can understand, that's not me in any way I can understand. That's Doctor Strange with a ponytail, some other dude. Yeah, that's the thing, is it's that's that. But you could say the same thing about your past and your future. You're like, the 10-year-old version of me is very different than the 30-year-old version of you versus the 1,000-year-old. These things are completely different dudes like us. I mean, if I were, and you can say they're not because there's a connection between them, but let's say I was going to go into battle, I wouldn't want the 6-year-old version of you. I'd want the 30 or 40-year-old version of you, right? Hey, Parker survived. He made it. Dude, you did it. I was like, he's probably.
Yeah, I went to the library.
Oh, nice.
To finish the conversation. I mean, you've got most of the material there anyway, so.
Yeah, no, it's not bad. But I was going over some of the things. Let me go back to the first one. Dimensional fabrication. Some of the questions we had while you were gone. Sticky Marks, thanks again for the £5. You're beautiful. VBD says about, let me go back to some of the earlier one he did. If the you as an observation can truly exist in more than one point in time and space, I guess omniscience means not seeing all points. What do you think about that? Do you think there's multiple dimensions mean that we're existing in multiple states, or are we different than each other?
I mean, I think the answers to those kinds of questions are in like psychedelic mushrooms and other things like that.
They have to do like empathy more than do with math. How about beyond engineering? How can you know if the math reflects reality? I'd argue that experimentation is insufficient proof of understanding. How about that?
How can you know if the math? That's the point. That's
Right.
part of the point. Can you put that back?
Yeah, for sure.
That is really part of the point. Like, are we in? Well, I think that's the importance of the phenomenological velocity, hidden dimension, instant. You want to talk about a Big Bang coming from non-existence, the oneness. If you multiply by 1, you have no effect.
But if you think
at 1, you're like entering your stream entering, But if you have that spontaneous, that, and I don't want to use Big Bang because I'm not really into Big Bang, but
it's the example.
Analogous. That's why this theory is so awesome, because you can find all these valid analogies between different concepts within this mathematical language. So I'm trying to tell people math is a great language. Math is a great language for expressing and, meditating upon and having ideas about stuff that's interesting. The premise that we can just make up these dimensions that have maybe that aren't from the delineated diagram. Well, where do they exist then? They exist in our consciousness. And consciousness, of course, we don't know how big consciousness is. It's probably infinite. And if consciousness is infinite, then maybe the universe just exists within consciousness. And I mean, but I think that people, words like mantra and tantra, or mathematical tantra, 12-dimensional pattern, hexadecimal patterns, these sorts of things. I think, the way they're building AI, an artifice of intelligence, these structures can be used to build an artifice, mathematical, linguistic artifice, tantric, mantric-based artifice. But I don't know.
So and I don't want to stop you because I know you've got still some stuff that you're going to point out, but I wanted to ask one more question before we continue, which was, and I've been pondering this while you were gone, future versus past. We exist in both places. We're like existing in multiple times at once, which is amazing because you exist in the past. If you go there you are, and in the future, but we're more aware of our past, not perfectly, but we have kind of this idea of memory of the past. We don't have memory of the future. What does that say about past, present, future?
Okay, past, present, and future. Well, when I started this investigation, I had the circle and the smaller circle. And as I liberated my perspective, I realized that, well, there's a paradox within, the folding of this. There's a paradox in the umbrella. So what did I do? I linguistically realized that not each variable is not the same. Like, you can't just say this variable is this variable. They're different from each other. Everything is different from each other. I have 5 fingers, but each one of my fingers is different. You might think they're comparable. They're not comparable. I can easily say they're not comparable to each other. And you can say they are comparable to each other. But so past and present and future and things like that, they're perspectives, I suppose. Negative, like each like, and there's so many different ways you can look at it. So some equations have 12 solutions, and each fragment of the equation, to call it that for lack of a better term, is plus or minus. Some equations have 2 solutions, a positive and a negative. So if they cancel out with each other, they cancel out with each other in a different way than multiplying by 1. Different meanings. We have different meanings. Just like we have different meanings of infinity. We have different meanings of negation. And they're all
ontological ways of looking at it, right?
They're all very particular to each particular one. And so to say past and present, they're just these broad words. They have no real semantic specificity, you know? So math can help us develop a more semantically specific language, I think, for talking about different things. But
so when you're using, in terms of dimensional fabrication,
it's just an idea. It's just an idea. Yeah.
And when we see this, though, what are you measuring here? How many dimensions are we looking at with this graph?
Well, the kind of dimension that this is an imaginary kind of dimension. It's a made-up dimension, doesn't really exist on paper, doesn't exist in the original diagram. But who's to say that that's not the real dimension, and that the diagram is the made-up dimension? Who can say? And so within all of these different forms, all of these different symbols, language, I mean, even that could be considered a moving symbol. I mean, the possibilities for this system are just endless. And I just try to introduce it to people as a way of thinking about stuff sometimes, you know? So.
Yeah. I mean, I love it. It's amazing. And it's great that you've got visuals as well, because I know that some people can't take the time to really do the math themselves, but they can look at it and they can see that what you're trying to say has to do with concave curvature. And what is canonical about a dimension? That's the other thought I was going to ask. Is a dimension an infinite plane, or is it canonical, or is it curved?
Well, like there's so many different kinds of dimensions. It all goes back which one you're talking about. We got number as a dimension, mass as a dimension, embedded dimension is a hidden dimension, curvature, that is a dimension. And so, like, for instance, we're talking about this is one layer. That's just the first step. You can do that over and over and over and over and over and over and over again. Or you can say there exists an infinity of this pathway of dimension such that so many back from 1 equals yada, yada, yada. So it's kind of like, it's almost like where you place a verb in a sentence, or where you place the article or an object in the sentence. Do you place the object before or after the verb? And so there exists the language is there exists an infinity such that, and then you notate using diagrams, equations. You notate different pathways that those can merge with each other and build new and other infinities or meanings, and some of them become quite imaginary. Some of them become quite theoretical. And that's okay, you know. Some of them, and so the oneness of all the imaginary infinities. Who's that? Jesus, you know.
Sticky Mark says, "Got to go," but calculus is broken. Never forget.
Yeah, calculus is broken.
Yeah, but I like what you're doing to fix it. The idea of infinities. Do you want to cover one more thing, or do you want to let them know where they can find more of your stuff?
I do want to cover a couple more things.
Yeah, what you got?
A couple more things. And thank you for your patience.
Oh, absolutely. I mean,
through this.
I struggle with order and I live for chaos.
I wanted you to bring up the shell diagram.
Yeah. Let me see where I have that. 1 second.
I really appreciate your having patience because I was kind of getting embarrassed that my thing was falling apart all the time. No, the yeah, but it's 3D.
This one or different?
No, it's I sent you a 3D object.
Oh. Okay, hold on.
Today. Yeah.
Is it
Original wave.
Original wave? Okay. I don't. Can I open this in 3D with the browser?
You can open it in preview.
Okay, let me open it in preview. 1 second. With preview, and then what do I do? Did I just close it? Give me a second. I gotta screen share preview window. Where we go? Preview. Thank you for your patience. There we go. And then share. Boom. Okay. There we go.
Right. But I mean, in the end, to me, like living beings are so much the most important thing. Because I've never seen anything as beautiful and magical and amazing as like I have pet pigs. So I just make a shout out for all the pet pigs out there.
Dude, pigs are cool.
Yeah.
Pigs are great. And so we got this point here.
Oh, yeah. And now see this object. And one thing I want to make really clear about this is like this object is approximately the size of the Earth. Like the Earth would fit nestled right. It's on the scale of the Earth. So you could fit the Earth literally inside one, like right there in the nook of that object.
So this is Earth, my friend. This is concave Earth. What are you trying to say? Is the Earth in the universe inside of a concave?
Sure. Oh, okay. The best way, I don't know, man. I just draw things sometimes, or I come up with things, or I do different stuff. I'm going to show you one thing here. Okay. You can, it's on my channel. It's called Google Earth, the curvature. Yeah. Okay. Here. And maybe, can you see that?
Yeah. 1 second. Let me pull that up. Screen share. So here we go. Okay.
So you can see there. That's the kind of.
So
that's the scale. That gives you an idea of the scale of the objects.
It's interesting because we experience all these things. It's flat or spheroid, but are we not just? Is that just not the experience of a multi-dimensional object? It's existing in
right. Yeah, we are built out of this mass matter. But if you look, okay, and the other interesting thing is that I don't know. I was reading a paper. I can't find the paper anymore, but it was relating the same forms as some of these equations that I found, but they were found through a different way. There was a different method, but finding some of the same coefficient harmonies.
Do you remember what they were doing?
Quantum. It was some quantum stuff. And they found the same coefficient harmonies that matched up formally right with my stuff. And so it's just, but so that's really interesting. With mass. So like if you took out a section of one of my solutions, that section would be equivalent to mass. And so mass is essentially made of space, spatioangularity, and curvature, and phenomenological curvature. Space, and that was giving really great evidence, But spatioangularity, hidden embedded dimension, those are what mass is actually made of. And that is in line with relativistic concepts. But yeah, and thank you so much for having me on the show.
Oh no, this is great. I'm loving this. And this is amazing. And I think we're opening up an entirely new, this is something, so many people are arguing with each other over whether or not their perspective is correct.
Yes.
Whether instead of just saying, because we know we cannot have correct perspective, can we do the math to figure out what the shared lens in between is? And I think this is it. This is great.
Yeah. And the acceleration of galaxies. Well, acceleration is the result of the Pythagorean theorems applied to the difference between two arc lengths, or the difference between the circumferences of the two circles. That's what acceleration is. Now, magnetism is extremely interesting, because if you take the derivative, if you take the integral of the height from any one of these algebraic transformations, if you take the integral of that height, well, what's the integral of acceleration? Velocity, right? So that's where a lot of these solutions are coming from. I integrate the height, interpreting it as acceleration, not just distance, but acceleration, because it has that character.
Yeah, inertia and distance, both, yeah.
The distance actually has the character of acceleration algebraically. So when it's in this algebraic form. So then when you integrate that, what do you get? You get velocity. And if you take the derivative of that, what do you get? You get jerk. And if you anyway, you can pair the you can pair with absiment. Right?
Right.
So
you get torque
if you
from
interpret it as distance, and if you interpret it as distance and you take the integral of it, you get absiment. And if you interpret it as distance and you take the derivative, you get velocity.
And from the absiment, you can take the rotary of the velocity and get torque.
It has something to do with magnetism, I'm convinced, because
spin state for sure.
The state is trying to reach that state of absiment. And so it goes through jerk, velocity, and it reaches eventually that resting state of absiment. But yeah.
Wow, this is a good one. I like that.
Well, I was going through a period. But yeah.
Okay, well, also high acceleration pairing. Let me open this one up too. 1 second.
This is a very important one, because this is where I found the new scale that I'm working with, the musical scale.
And it's a 12-base scale instead of 8, you said? Or
but you can check out some of the harmonies. I published one album in that scale.
Wow.
So far. So yeah, just go ahead and scroll down. You'll see it. And there you go. So you see all these coefficients. I'm doing music in this scale. And
wow.
it's like a lot of work. You have to like program the synthesizer and take each wave sample and put it in. It's a lot of work.
This sounds awesome. I can't wait to hear this. I mean, so where do we find that?
On my channel? My channel is called My Blog Band.
Okay, hold on.
I used to do this collaborative music website thing, and I have these patents. And it was related to AI and how robots could talk to each other. And I don't really want to do it anymore, because it's just like
they've already got robots talking to each
other.
Yeah,
they're doing this.
Is it Forward, Backdoor?
Very old album. No, it's called Prince Puzzle and the Master Formula.
I don't know if I can get the audio to. Can you hear that?
No.
Is the audio? I can't get the audio to play out of this.
Right, just for you, just for you to check it out.
Guys, you're gonna have to look this up. It
Yeah.
sounds really good, though. Actually, it's got some of my favorite kinds of Gammel bell and dial-up, and it's nice.
Yeah. No, and I plugged the let me plug one more thing, is the Aramaic New Testament, because it's a much better translation. I mean, the guy did great work.
You don't have it on your
David
site?
David Boucher. He did the Aramaic New Testament. He translated it from the Peshitta. And they took when Jesus said, "I am Jehovah," quote, they took that out of the Bible. And he went to in the Roman Catholic Church, And they took that out, and I think it threw off a lot of people. I really do. I think it threw off a lot of people. So
let me find the
that's it. Aramaic, English, interlinear New Testament.
I remember, like, for an example, is this the one? The Aramaic Lord's Prayer is so, you've heard like, oh, our Father who art in heaven, right? But this version, the Aramaic is like, oh, thou from whom the breath of life comes, who fills all the realms of sound, light, vibration. It's like, what, how do they miss all this? How did you under translate this? This is a lot here. Your heavenly domain approaches. Like, this is, heaven on earth is, this is better in the universe, just as on earth. I mean, it's a deeper deal. You're going to want to check that out,
I guess.
Right?
Right. Thank you so much for having me on the show, Andreas.
Parker, I appreciate it, guys. You're going to have to check out the links below to get his books. I'm going to have all of the PDFs that you can get, and also check out his channel, subscribe, listen to his music. Parker will do it again soon. We should do another thing on the practical applications of math, because I think there's some people that are still a little traumatized by high school and junior high math teachers that were alcoholics. And
I hated math. I mean, I don't do what you hate, but I tackled it on anyway.
Well, I mean, if you like painting and you like music, then you love math. You just don't realize it yet, So there's that. But Parker, thanks a lot. We'll see you next time. And everybody, tune in tomorrow for more.
Bye.
There it is.
Hey, everybody, tune in to Recent Tartarian.
Recent Tartarian. Recent Tartarian. Tartarian. Recent Tartarian. Recent Tartarian.
Hey, everybody, tune in to Recent Tartarians.
Recent Tartarians. Recent Tartarian.